Greetings, this is Artie from Artifact Electronics. So I bought something, came in the mail today, and let's have a look at this thing and see if we can fix it. What is it? So what we have here is a pristine Radio Shack Model 1 power supply. What? You actually paid money for this? Yes, I did. And the reason for that is as follows. First of all, I like the Model 1s, my starting computer. Second of all, they do come up once in a while, but more often than not, you get the computer itself, but there's no power supply with it. Because everybody thinks, oh, it just takes a regular power cord and, no big deal. Well, no, it doesn't take a regular power cord. It has kind of a weird transformer, weird voltage output in it. And best of all, it's an original power supply. So, let's have a look and see if we can bring this guy back to life. So at least it looks like it's complete. It's got a power cord, non-grounded, and it's got a 5-pin DIN connector that plugs into the computer for power delivery. And then other than that, it's got a fuse hanging on the outside. It is taped together. Obviously it was cut open. Some of these actually had screws underneath the rubber feet, but I guess this one didn't. So somebody dremeled it open and tried to fix it and then gave up. The most common failure on these is that there's a fuse on the primary, and if that fuse blows, obviously if this case doesn't have screws or isn't to be opened easily, it was never intended to have the fuse changed. It was just a safety feature, and if the fuse blew, well, you just had to go and buy yourself another power supply, which in the late 70s, early 80s, most likely wasn't a big deal. You just swung to your local Radio Shack and got another one. But nowadays, they're not that common. And people, of course, have come up with replacement power supplies that you can build yourself, but they'll run you about $100 with a decent case, if not more, to build one, and it'll look totally unoriginal, whereas this maintains the beauty of the original. I paid like $22 shipped for this thing, and it was made in January of 1980, well into the life of the Model 1. Okay, let's see what awaits us inside. Ugh. It also smells like it sat in the basement for a while, for a really long time actually. Even the electrical tape seems to be disintegrating. Ugh. So here you go. It basically, it's got a transformer. And I'll show you a diagram. I've drawn a diagram of a previous one I repaired. And the fuse, the original location of the fuse was, of course, here, using a pigtail fuse. And this one was either damaged or blew up or whatever. So I guess what they did is they got sick and tired of blowing that fuse, so they put an external fuse holder on it, which I guess this connects to here, and hung it on the outside so they could rapidly replace it. Let's have a look at what's in here. Wow, what's in here is also blown. And let's have a look and see what the value on this fuse was. I mean, obviously the one in here you can't read anymore. And this one was a half amp slow blow. So now to double check on that, let's look at the ratings. Again, you can probably, oh yeah, you can see that, but I can't. Anyway, it says that the input on it is 120 volts, 50 watts. So the quick and dirty way is to basically divide 50 by 120, which is about 0.6. So this is looking for a 0.6 amp fuse, and this fuse was 0.5, but it's a slow blow, so for all intents and purposes, it's a good replacement, or was a good replacement. So what we got to do here is, first of all, we got to put this thing on a variac and bring it up slowly to make sure that the reason the fuse blew was not because of what it was hooked up to. Well, actually, we got to make sure that it was whatever it was hooked up to blew the fuse on it, and that we don't have any shorts in the transformer itself, because if the transformer is shorted, then this thing becomes completely useless. But first, let's have a look at what the interior on this, what the schematic of this looks like. And I fixed one previously, and I actually found my notes on what it looks like inside. So let's have a gander at that. So from the notes I dug out, this is what the other one looked like. And just saying beforehand, I think the one we have on the bench now is pretty much the same. So essentially you got your 120 volts AC coming in, running through a fuse, which we determined, what was it? Oh, 0.6 amps or 0.5 slow blow. Let's say 0.6. And so that's the primary. We have two secondaries, which are both center tapped, and the center taps are tied together and actually supply ground to the system. We then have, and I read these on the back of the case, it does supply 17 volts AC, which comes out of the first primary, and these are the wire colors used. As you can see over here. So this just provides 17 volts AC. This is just a transformer tap with nothing happening in here. And then the second secondary actually has a rectifier in it, is also center tapped, and feeds the red wire with 19.8 volts DC, which is with reference to ground, of course, which comes from the center taps. So again, these were the wire colors, and the numbers in parentheses are the pin numbers on the connector going into the computer. And so we know what's supposed to be where. And the only thing is, I guess, pin 5. Pin 5 is a no connect. And all the others are. So here's our schematics, and that's all we should need to basically go in there and check this thing out. Oh, and the diodes are, the ones that are on there, I can't read what they are, but to make an educated guess, probably a 1N4001 would be a good choice for that. Alright, so we have the theory in place. Let's now see what comes out of this guy. Okay, so I resoldered this wire that was off. That's basically the fuse for the primary. I'm going to put in a half amp slow blow. I don't have a 600 milliamp fast blow. And then we should start monitoring. Let's monitor the 17 volts AC. Give it some input, bring up the variac slowly, see if the fuse blows, and see if we're getting 17 volts AC. Alright, so the first test is that we have the variac hooked up here. We put in a fuse. Oh, I guess I didn't film something small, but one of the first steps you should do that I did do is to basically measure the resistance for all the wirings to make sure that none of the windings are shorted, because otherwise, well, if any of them are shorted, then that's the end of the video, but none of them were. They showed in the few ohms range. I don't know exactly what they're supposed to be, but that looked good. So I got the meter hooked up to the 17 volts AC output, and so for now what we're going to do is give it some juice. It's turned off, power is on, and this is basically the voltage here. 120 is over here, and this is what's coming out of the 17 volt AC, which is showing 300 millivolts right now, AC. So slowly turning this up, no sparks, no fires, no smells. That's good, actually. And the current meter on the variac is sitting at 0, so that's even better. So now let's go up to 100 volts. No sizzle, no pop, no nothing. And we're sitting at 15.6 volts AC. Remember, we're looking for 17 volts AC. So let's adjust this to 110 and 120. And it's giving us 18.8 volts AC. Since it's a no-load situation, I think that part of the transformer is working correctly. So next we got to check the DC output and see what that looks like. Okay, now we are hooked up. AC situation just as before, but now we are going to measure DC from here to ground, and we are expecting 19.8 volts DC. But it'll probably be a bit higher because, again, we are in a no-load situation. So let's double check. That's ground. That's hooked up to the diode. And double check something here. Yes, it's hooked up to the cathode of both diodes. So the meter is going bananas. Okay, we are getting a DC voltage. Don't have to go as slow as we did last time, because obviously it's already passed the acid test. and 120 volts. The DC is a bit low. It said 19.8, but we're only getting 16.4. But knowing how this is going to be used, I mean, this is essentially driving the 5-volt regulator, so I think we're good. I'm going to let it sit for a while. And don't try this at home, boys and girls. There are live AC voltages in here. And so if you don't know what you're doing, don't do this. Otherwise, this is how you would do your preliminary, not just preliminary tests. We've actually tested, we've seen that the voltages are correct. A little low on the DC, but I think still sufficient for driving the computer. So what we got to do next is, I think what we should do is to make sure that the right voltages are actually coming out of the DIN connector. Because when it comes time to test this with a TRS-80, I'm going to make damn sure that the voltages that are in here aren't going to fry it. So let's hook that up. Okay, so we are clipped on to actual pins 2 and 4 on the DIN that are supposed to supply our DC voltage, which is listed at 19.8, but we saw, what's 16.5 or something. So, and we're going to live dangerously. I'm just turning it on. It's still sitting on 120 volts. All right, so that voltage is getting to the correct pins, and all that's left to do is check the AC voltage on these pins, and that actually concludes the testing segment. All right, now we're hooked up to pins 1 and 3, which, I don't remember, but give us something, what was it, around 18 volts AC. And 19 volts AC. I think that's about, yeah, but that's correct. So we got correct voltages on all the pins over here, and now comes time to do a little bit of physical restoration on this, get the fuse back in there, clean up wiring, get all that sticky goo off of this thing, and other such nice things. And then we'll actually plug it into the TRS-80 and see if that thing powers up. Oh, I could hear one of you yelling, "Hey, don't be sloppy. Check the diodes. You have a low DC voltage." All right, I shall do so. Here is where the diodes cathodes are tied together. Here is one of the diodes. Looks good. Here's the other diode. Looks good. I mean, one way to explain the low DC voltage would be if one of the diodes had opened up, but nope. I guess everything's doing what it's supposed to do. Back to the cosmetics. One not so small issue that I had overlooked was that I'm going to have to mount a glass fuse over here. And there isn't enough room for it. I guess originally they had a pigtail fuse in there, and I didn't have a 0.6 amp pigtail fuse, so I tried all sorts of things using fuse clips, fail, inline fuse holders, fail, there's no room to mount them, a real fuse clip, which kind of fit in back here, but it touched the laminates on the transformer, and So I was getting ready to throw in the towel for tonight, and I went and looked through my fuse collection, and I found this wonderful site, which is what I've installed here. Problem is it's a little bigger than what we should have. It's a 3/4 amp rather than a 0.6 amp, but that's just going to have to do. Fits perfectly. Doesn't touch anything else, doesn't impede the case from closing. So I think now is finally the time to test this with a TRS-80 before we actually put the case back together again. Okay, we're all hooked up. Video into the TRS and our new supply. So let's see if it worked. Here we go. Beautiful. Let's see. Oh, I've been typing on the PET where you don't hit shift to get double quotes, so. Okay, let's do this. Clean away, print. It works. And go to 10. There you go. Not getting too hot. I'm going to let this run for a while. And then we can finally get to putting the case back on it and cleaning all that dirt and tape residue and everything off it. Figuring out how we're going to keep that case held together, preferably without electrical tape. Well, I cleaned up, but I couldn't come up with a good way to hold the case together in a temporary fashion. Because if I super glue it and something goes wrong, I have to cut it apart again. Thought of sticking long screws through the corners, and so I did what I hoped I wouldn't have to do, and I taped it. Seems sturdy for now. This is like the better Scotch electrical tape, not the 50-cent one you get from the corner store. And let's see how long this holds. I mean, the point is, if this works for a while without hiccuping, I'll probably super glue it together, and it'll be my backup supply, or when I find another TRS-80, I'll already have a supply for it. Thanks for watching. Please like and subscribe, and don't forget to comment. We'll see you next time.